All right, here are the ground rules. 1, these are the 4 rays that we're going to be addressing. The P ray, the F ray, the C ray, and the M ray. Excellent. So, you also need to know, ground rule number 2, that when there is an object, and my object's gonna kind of be like this thing right here, it represents any possible thing. I guess if this object gets bigger, it would look like that, and if it flipped over, it would look like that, and I guess it got shorter there also. But remember that rays of light are coming out from this object if it is a diffuse reflector, and I hope that your object is. If you want to look at something that's a specular reflector, then you'll have trouble really seeing what it looks like. What does a mirror really look like, right? So Newton, though, is lovely because you can see him from every angle because he's getting hit by light from everywhere, and he's also reflecting that light from everywhere. And that's because the surface of Newton is really bumpy, like on a microscopic scale. The surface of a mirror is like that, though. So every ray that comes in comes out at the same angle where those guys are equal. But here, you got a ray coming in, and there's a chance it's going to go that direction. And if it's a little bit over, it's going to go perhaps that direction. If it's right here, it's going to go that direction. This is a diffuse reflector because light's coming out every possible direction. But we're going to be studying only the 4 principal rays that we discussed just a moment ago: the P ray, the F ray, the C ray, and the M ray. Here we go. When I was a small boy, my parents took me to Wyoming, and at a quick trip, an old decrepit man came up to me on my way to the bathroom, and he said, "Son, take these scrolls, they may be useful." And he handed me this packet. And it's time, it's that point in my life when I'm ready to understand what he meant and why he gave them to me. And, there was one more thing that he said. He said, always remember the line of action of the mirror is not the mirror's surface itself. It has to be drawn where the principal axis intersects the mirror itself. All right, so he clearly has drawn for me an object on each one of these scrolls, and we'll have to find out where the image is formed. And perhaps it will be the key to a puzzle. I'll start with the P ray each time. And the P ray comes in parallel, and it's gonna be like this. And then it will bounce out through the focus, and the focus is here, so it will go like this. And I am going to put arrows on the outgoing rays so that I become clear on how this is working. The next ray is the F ray. The F ray comes in through the focus. Watch it, wait for it. It hits the line of action of the mirror and comes out parallel. There it is, coming out parallel. And that is our F ray leaving. And then the next one that we like to discuss is the C ray, which is coming straight through the center and going back out straight through the center. Oh boy, we've got ourselves a little problem, Houston. It's gonna be like this. Whoa, not like that. It'll be like that, where that's our C ray, hitting the line of action of the mirror, coming right back out. And then, well, I guess there's one more ray. Let's just go crazy and draw ourselves an M ray. I like to use blue for my M ray. The M ray will be hitting the center of the mirror, where it hits the principal axis and bouncing back out at the same angle. Looks pretty good. There's my M ray. Where all 4 of my rays intersect, it is there that an image is formed. Because see, it's like this. This is like, here's a little bit of image theory. This thing is clearly a source of rays, and they're diverging. They're all going out here, and they're spreading apart from each other. And we've only drawn 4 of them. There are really a multitude, an infinite number of rays coming off in all possible directions. But as these rays go and hit the mirror refocuses them. They were spreading apart, and now they're converging again. Look at them all coming in here, and they're ready to say, hey. And if you put a piece of paper right there, I can't use that color. I need to use the color for the object, I think, so I don't get confused. If you put a piece of paper right here, a screen as it were, then you would find an image. So let's label these things right here. You've got your object, and you've got your image, and wherever 2 rays outgoing intersect, then you will have a real image. It's real because there's actually light there, and if you put a piece of paper there, you would see something. You would see the arrow or the flower pot or whatever you had here as your object. I hope it's a flower pot. All right, so if you've got a real image right here, you can ask questions like, how tall is that image? And so the height of the image could be a question that you want to know, and the distance of the image from the lens as well. I already wrote down that the height of the object was 4 centimeters, and it's 18 centimeters away from the mirror, so we expect the height of the image to be a little bit less, and we expect its distance from the mirror to be a little bit less also. I am getting that it is 2.3 centimeters. 2.3 centimeters, but guess what? It's negative! So I'm going to quickly change this so it says height of the image is negative 2.3 centimeters because it's below the line, all right? And the distance of the image, well, the distance of the image, it's on the proper side of the mirror, and that seems to be 9 centimeters. 9 centimeters. Interesting, this is like a factor of 2, and that's like a factor of 2 with a minus sign in there, but clearly the image is smaller than the object. So we go to his next clue. His next clue is an object at the center. Oh, dang. We put a line of action down. Here's the line of action of the mirror, and we're going to be acting on that line of action, and we need to make 4 rays. The P ray. P ray comes in parallel. Ready? Wait for it. Here's our P ray, parallel to the axis, and it goes out through the focus. Pew! That is our P ray. And then we've got to have a, dang, I lost that cap. Sorry. F ray comes in through the focus, comes out this direction parallel to the axis. Okay, and oh shoot, this is so badly done. Unbelievable. All right, well, we're gonna have to fudge it a little bit on the next ones. We've got a C ray that is coming through the center and bouncing out at the same angle at which it came in. And it looks like it ought to be something like this. That's our C ray, and then an M ray comes in through the middle, and oh gosh, did I say that was the C ray? That's definitely not the C ray. That's, oh no, that's the M ray. The C ray, to switch colors on you, goes straight through C and then hits the mirror, or does it? No, it doesn't really. So I've got these 3 that are intersecting right here. You see that? I've got those 3 that are intersecting right there, and I've definitely got an errant, what is this? This green one? That's a P ray. That P ray really sucks, and I'm not sure why. Well, anyway, don't worry about that. If you've got 3 that intersect at a certain place, that's definitely telling you something. And I'm going to say then that my image is right here, where these guys are hitting. So there's the object, and here's the image. The outgoing rays are converging right there. And the cool thing is they're at C, which is really cool. So notice it's just about the same height. I'm not going to bother to measure it. It ought to be the same height. The height of the image is also 4 centimeters, but it's negative. It's down below the axis, and the distance of the image is 13 centimeters. So cool. That's, again, the same ratio. Everything's equal with a minus sign there. Next up, they've put the object in between the center of curvature and the focal point. So, okay, we're gonna have to be careful. We need a P ray. The P ray comes in parallel, and, oh, line of action. My apologies. Line of action right here. The P ray comes in parallel and goes out through the focus. You should be drawing these at home. Do it. And then we're going to get you an F ray, and the F ray is supposed to come through the focus and go out parallel. Notice there's a lot of room for error here. If I'm just slightly off, then everything's going to be crazy. But there is my F ray. And let's keep going. We need a C ray, and the C ray, whoa. The C ray doesn't really make much sense, does it? So the C ray comes as if it were coming from C, but it leaves the object. Really, that's what's supposed to happen. It's supposed to leave the object and go that way. That's the beginning of my C ray. It will ultimately hit the line of action up here, way up here, and then it will come back down through the center. And it'll be going that direction when it comes back down. So that's my C ray, a little bit weird. Okay, and then I want to give you an M ray, and the M ray is supposed to come off of here, hit the middle and bounce out at the same angle. Let's see what the M ray does for us. I'm thinking that the M ray is probably going to be shooting somewhere like right here. Well, we could aim there if you want, or we could aim there. I don't really care. I'm going to kind of split the difference and say that the image must be somewhere in between all of these things. So these 4 lines should be intersecting at a single point, but they're not. Go figure, they never quite do. And this is approximately where my image is. So we've got an object here, and we've got an image here. Notice that the image is still inverted. It's upside down, but it's bigger now than the object is. So if I'm in between C and F, then I get this, oh man, the image is inverted. So I'm going to say the height of the image is negative something. Let's find out how big it is. It looks like it's negative 6. And the distance of the image is 16. The distance of the image is 16 centimeters. This is on the proper side. So it kind of looks like we're doing a 50% increase kind of thing. These ratios all kind of make sense. So let's go to the next puzzle and oh, it's at the focal point. Let's begin. We need a P-ray. P-ray comes in parallel. Oh, we need a line of action first. Line of action. If you're getting bored, you can stop watching this because I'm doing the same thing every single time. The P-ray comes in parallel, hits the line of action, and goes out through the focus. Oh, interesting. Wait a second. I probably should continue this a little bit more. All right, and the next one is the F-ray. The F-ray is supposed to go out through the focus, and that can't really happen. It's never going to hit the mirror, so I'm not going to draw the F-ray. My C-ray, though, my C-ray is supposed to start as if it had come from C. So it's going to be like this. It's going to be kind of like this. It's going to be kind of, and then it's going to come back out in the same way and try to go back through C again. Supposed to be straight here. And that guy was leaving also. And there's one more ray that I can do. My M ray is supposed to go through, I didn't quite hit C there, but I'm trying to make it look pretty, so I have to cheat a tiny bit. There, and then it's going to come back out at the same angle at which it entered, and it's going to be doing that. So we've got 3 rays, and these rays, well, where are they going to meet? Haha, I'll tell you. They're going to meet at infinity, which means my object is at infinity, and it is infinitely big. Wait a second. You're saying right now that the height of the image is negative infinity, and you're saying that the distance of the image is infinity? Cool. That means we have some very interesting magnification going on. I guess it's infinite magnification, but the issue is if you looked at the image on a screen way over there, you would find that it is, well, still taking up the same fraction of your field of view because it's infinitely far away, but it's infinitely big, so you can still see it. Lovely. Does it make much sense? Not really. Putting things on the focal point is kind of weird. There is no converging that happens because that's the essence of a focal point. At the focal point, if you send something in, you're going to get out parallel rays, so you don't get an image formed. But really, there is an image, it's just infinitely far away. I don't want to talk about this anymore. Let's go on. There's, oh dang, and the final scroll, we put more space over on this side. Let's see what he's going to do. We need a P-ray. The P-ray comes in here parallel and then goes out through the focus. Like this. The P-ray goes out through the focus like that. And then, what's the next one? We'll do the F-ray. The F-ray comes as if it had started at the focus. See, that's what it's all about. It's like, it's not going through the focus, it's as if it started at the focus, and it's going to hit the line of action of the mirror. Oh no, I forgot my line of action. Never forget your line of action, students. Never, 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 never do that. So I'm supposed to go out through here as if I came from the focus, and then when I hit the line of action of the mirror, I'm going to go out parallel. Watch this. I'll be like, pew, pew. So it's all that direction and such. And then, oh, this is kind of weird. We've got a couple more that we can draw. The C-ray is as if it had started at C, and then it will go back towards C. So it'll come The order of doing this is pretty important. It's going to go towards the mirror, and then it's going to hit the mirror, and it's going to bounce back that direction. So when it gets to here, that's an outgoing ray again. And then there's finally one more ray. The M ray is going through the middle. One more principal ray going through the middle and coming back out at that same angle, which is probably something like this. And you notice that these rays will absolutely never cross each other, but something very interesting is happening. It's as if they once crossed each other. That's a little bit weird. But if you put your eye over here, you could look. Here, put that pretty blue eye right there. You look in this direction and you're thinking, wait a second, those rays seem to be coming from an object. There might be something over there. Shall we consider whether there's something over here behind the mirror? There's nothing here but darkness. All the light is over here. But it's as if something is over here causing an image, causing these rays to come out from each other. So let's trace them back. I'm going to trace where it looks like this blue one came from. It looks like the blue one came from over here, somewhere. And I'm going to trace where this orange one came from. It looks like the orange one came from right here. Oh, sorry about that. And it looks to me like the purple one came from... Oh gosh, that's really disappointing. Okay, well, we'll just deal with it. The purple one looks like it came from over here, and the green one seems to have come from right in the middle of all of these. Good. I got 3 lines that worked out, and my C ray is just the absolutely terrible one. I think I maybe didn't measure where my F and C were in relation to each other quite well. So there is apparently something here. There's apparently something here. Is there something there? Of course not. It's dark on the other side of the mirror. But your eye thinks that there's something there. And that's how we can use this kind of a mirror as a magnifier. Because when I look at it, I see not the object, I see the image as even bigger than it actually is. So the distance, well, let's see. First, the height of the image. First of all, it's positive. That's pleasant. And where the object was 4 centimeters, this sucker is actually 9 centimeters. Oh, cool. What about the distance of the image? Well, it's on the wrong side of the mirror, so that's offensive to me. And I'm going to say that that distance is about 4 centimeters. Cool. So what we've got right here is not real. It's a virtual image. 2 properties of virtual images that I want to note. 1, it's upright. 2, it's on the wrong side of the mirror. There's nothing there. If I put a piece of paper right there, I would not see anything because there's no light there. It's darkness. That's all I have to say with this. We're going to do some convex mirrors next. They're a lot easier. All right, here are the ground rules. 1, these are the 4 rays that we're going to be addressing. The P ray, the F ray, the C ray, and the M ray. Excellent. So you also need to know, ground rule number 2, that when there is an object, and my object's going to kind of be like this thing right here, it represents any possible thing. I guess if this object gets bigger, it would look like that, and if it flipped over, it would look like that, and I guess it got shorter there. Also, the P ray each time. And the P ray comes in parallel, and it's going to be like this. And then it will bounce out through the focus, and the focus is here, so it will go like this. And I am going to put arrows on the outgoing rays so that I become clear on how this is working. The next ray is the F ray. The F ray comes in through the focus. Watch it, wait for it. It hits the line of action of the mirror and comes out parallel. And he handed me this packet. And it's time, it's that point in my life when I'm ready to understand what he meant and why he gave them to me. And, there was one more thing that he said. He said, always remember the line of action of the mirror is not the mirror's surface itself. It has to be drawn where the principal axis intersects the mirror itself. All right, so he clearly has drawn for me an object on each one of these scrolls, and we'll have to find out where the image is formed. And perhaps it will be the key to a puzzle. I'll start with equal, but here you got a ray coming in and there's a chance it's going to go that direction, and if it's a little bit over it's going to go perhaps that direction. If it's right here it's going to go that direction. This is a diffuse reflector because light's coming out every possible direction. But we're going to be studying only the four principal rays that we discussed just a moment ago: the P ray, the F ray, the C ray, and the M ray. Here we go. When I was a small boy, my parents took me to Wyoming, and at a quick trip, an old, decrepit man came up to me on my way to the bathroom, and he said, "Son, take these scrolls. They may be useful." But remember that rays of light are coming out from this object if it is a diffuse reflector, and I hope that your object is. If you want to look at something that's a specular reflector, then you'll have trouble really seeing what it looks like. What does a mirror really look like, right? So Newton, though, is lovely because you can see him from every angle because he's getting hit by light from everywhere, and he's also reflecting that light from everywhere. And that's because the surface of Newton is really bumpy, like on a microscopic scale. The surface of a mirror is like that, though. So every ray that comes in comes out at the same angle, where those guys are